So this video is all going to be, it's going to be all about circular motion. Okay, so up until now, what we've all been dealing with has been basically motion in one dimension. We did a little bit of stint in two-dimensional motion with projectile motion, but this is going to be something a little bit different. So we know that the law of inertia says that if an object is moving, say this direction, then nothing's going to, or it's going to keep doing that until something changes. So maybe there's a force that comes in, gives it a little bit of a kick, and then all of a sudden it goes off this direction, or more likely it's probably going to go off in this direction, because now it has that change in its velocity because of the force. So what causes something to move around in a circle? So let's think about something that moves around in a circle. So let's give an example here. How about how about some keys on a lanyard? So here's a guy, right? Kind of looks like me, and there's his hand, and he's swinging some keys on a lanyard, and so there's the keys. Okay, I can't draw a key. So these keys on a lanyard, he's swinging it around. Then this whole thing is going to just keep going around in a big circle, 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 circle. And the question is, why does it go around in a circle? The keys, if I were to let go of them, would just fly off in some random direction. So why does it keep going around in a circle? Well, you might have a pretty good intuition here, and it has to do with this lanyard. There's a force. There's a force directed inward towards the hand along the lanyard itself, and we would call it a tension, that is causing this object to move in a circle. And the reason for it is because this force, the tension force, is always perpendicular to the direction of motion. So let's think about this. If you are, let's say, in a car, right, and you're driving down the road, and I don't want that view. So here's, there we go, a curve. Here's you in the car, okay? You're driving with some friends. There we go. There's the top of your heads. So it's going forward. Now, when you hit the turn, what happens to you? Well, you seem to get thrown to the outside of the turn, outside of the curve, when the car starts to make the turn. And the reason for this is because you want to keep on going straight. Your inertia says, hey, I want to keep on going straight. So you end up getting thrown to the outside. Why? Because the car itself begins to turn. Okay, there's everybody here. The car itself begins to turn, so the outside of the car is actually pushing you inward, causing you to make the turn. There we go. Okay, so this type of force that we have both here when we're looking at the tension of a string or a lanyard, causing it to go around in a circle, and then this force of you going in on a curve, we call this a centripetal force. Centripetal force. Centripetal basically means center seeking. It is towards the center. Okay, centripetal force. And according to Newton's second law, all forces should have the equation F equals mass times acceleration. And this is no different. It's just that we're going to say something different about this acceleration. This acceleration doesn't necessarily go to change speed, it goes to change your direction. So let's think about that. I could go around this curve at a constant velocity. We have a velocity of, say, 50 miles per hour here. I could have 50 miles per hour here, and I could be going 50 miles per hour here. Okay? You're not changing your velocity. Technically, you're not changing your speed. You are changing your velocity because your velocity is going in a different direction. That speed is going in a different direction. Now let's think about this right here. Okay, what if the ball happens to, or the keys happen to be right here? It's moving this direction, and I can cause this to move it in the same speed all the way around. Now it's here, now it's moving this direction, now it's here, now it's moving this direction. So it is just changing your direction. So we would call this a centripetal acceleration. The centripetal acceleration has a specific equation for it. Centripetal acceleration is equal to v squared divided by r. Okay, we're not going to go into the reason why it's v squared divided by r. You can do a little bit of research on your own if you really want to know. but it has to do with how that vector is changing and what acceleration means when you're talking about a change in velocity. So it's v squared over r being the radius of the circle that you're traveling around. Okay, so in this case, r does mean radius. You want to kind of keep that in mind because sometimes r just means distance, sometimes r means radius, and they can get a little confusing. So what does that mean about Newton's second law, F equals ma? So that means a centripetal force is equal to mass times v squared over r. So we have two equations here. Okay, we got this one right here, which is just talking about centripetal acceleration. Excuse me, and then we have one here that talks about the centripetal force. So let's think about this for a second. Let's say you are, well, let's go back to you in the car. Okay, so here is the road, and you are currently mid-turn. There's everybody. If this were to continue to go around in a circle, that radius might be something along the lines of, I don't know, let's say 15 meters. Okay? And we're going along in a circle. And we're going along at a constant speed of, let's say, 30 meters per second. So what is the centripetal acceleration? Well, the centripetal acceleration would be v squared divided by r. So that'd be 30 squared divided by 15, 900 divided by 15 gives us what? We're looking at our calculator. 900 divided by 15 gives us 60. 60 what? Well, it's meters per second squared. How does that work out? Well, this is a meter per second that gets squared. This is a meter. So you have meters squared per second squared divided by meter, and it does actually work out to have the same units as acceleration. So that is our acceleration. So what is our force? Well, if we're talking about the force on you, maybe you have a mass of, let's say, 60 kilograms. So if you have a mass of 60 kilograms and an acceleration of 60 meters per second squared, what is your force? Or what is the force that's causing you to make this turn? Well, it's mass times the centripetal acceleration, or 60 times 60, which comes out to be 3,600 newtons. Okay. If we take a look at another example, let's talk about the keys on their circular journey. Okay, maybe the keys have a mass of, let's say 1.2 kilograms. That is a huge amount of keys. So let's back that off and let's just say half a kilogram. Okay, and then my lanyard is, say, 1/2 of a meter. So what if I just asked with this, what is the centripetal force? So centripetal force. We could just jump straight down to mv squared divided by r. Well, there's a problem. We know r, we know m, do we know v? Well, what if I told you that it makes this circumference, makes it a trip all the way around once, and it takes, let's say, 2 seconds to do it. Okay? So its velocity is really the circumference divided by the time it took to go all the way around. So the velocity would be 2 pi times r over 2 seconds. Okay, make sure that you can follow me here. The speed that the keys are going around in a circle is the distance that it travels divided by the time it takes to do it. Well, the distance it travels is the circumference of that circle, and that circumference is calculated as being 2 pi r. So velocity being 2 pi times the radius of 0.5 meters divided by 2 seconds, that would be pi times radius, so 0.5 times pi, which would be about 1.57 meters per second. So now we can actually calculate this. We'd have a mass of 0.5 kilograms. We have a velocity of 1.57 meters per second. And we have a radius of 0.5. 0.5's cancel out. We're left with a centripetal force of 1.57 newtons. Okay? So a big takeaway from this is that, hey, you have to have a force in order to make something move in a circle, and that force is known as the centripetal force. Centripetal force has basically its own equation to calculate it, and any force that causes it to move in a circle could be considered a centripetal force. So think about what other things move in a circle and what forces are used to create that circular motion. Okay.